Hello guys, welcome back to VC Tech. In today's video, we are going to be diving into one of the most important and powerful topics in network security, which is port security. I'll be using Cisco Packet Tracer to configure port security on a switch, and I will explain what port security is and why it's important, and how you can set it up to protect network from unauthorized access. As you can see, I have one switch and I have three laptops that are connected to the switch, and I also have one laptop here that we'll use for the practical. So each port on the switch represents a connection point to the network. Now in real life, we don't want just anyone plugging into a switch port and gaining access to our internal network, and that's where port security comes into play. So with that being said, what is port security? Port security is a feature on Cisco switches that allows you to control which devices can connect to a switch port based on their MAC address. It helps prevent unauthorized devices from joining the network. An example for this is going to be if someone plugs in their laptop into the office switch, the switch can automatically block it because the MAC address is not recognized. Think of it like an event that requires a guest list. If your name is not on the guest list, you cannot gain entrance into that event. So with that being said, guys, let's head over to the configuration phase where we get to see how port security is being configured on a switch. So as you can see, we have, let me just go back. So we want to configure port security on this interface FA0/1. So we say interface FA0/1. We want this to be switch port. We want to be access port. And we also want to specify switch port security to let the router know that for this interface we are activating port security for this interface. We also want to specify the maximum try, like how many times they are supposed to try before the interface goes down. So we want this to be just one time, and we also want the switch to be able to recognize the MAC address of each PC. So we do that by saying MAC address, and there are two ways to gain MAC address. One, we could do it manually by going to the PC and going to command prompt and just say ipconfig/all. So this is the MAC address for this host laptop. So you could just copy this and paste it here, so the switch can know the MAC address of the PC. However, we can also do that by saying sticky for the switch to collect the MAC address when the PC pings another PC on the same local area network. Now, what happens when unauthorized device try to access the switch port? We want it to shut down because a violation should be shut down. So by doing this, we've configured port security on the interface of interface FA0/1. Let's also do the same configuration on interface FA0/2 and 3, then we test for connection. So interface FA0/2, we want to say switch port mode to be access, and we also want switch port security to let the switch know that we want to be using port security on interface FA0/2. So we also want to specify the maximum try. The maximum try should be 1. as well as the switch should obtain the MAC address of the PC via sticky mode. And the violation for this, let's use restrict. Let's also do for the last interface FA0/3. Switch port mode should be access, and switch port security. We want to specify maximum try to be 1, and obtain MAC address via sticky mode. And the violation for this should be protect. Now let's do something. Let's check if the switch has a MAC address of any of the PCs, because at the moment we've not pinged any of the PCs. So I doubt if the switch would have the MAC address of the PCs. So we say do show MAC address. So as you can see, the MAC address table is empty because we've not pinged any of the device. Let's try to ping from this device. We do not have IP address, do we? No, we don't have IP address. So let's assign IP address to the host PCs and try to ping from each device, so the switch can learn the MAC address of the devices that is connected to it. Let's also assign IP address to this. One take .3 and the other one take .4. So we've assigned IP address to the host PCs. Now let's try to ping the devices so the router can learn the MAC address of the devices that are connected to it. So let's ping 1.2. Let's also ping 1.3. And now we are able to ping the devices in the network. Let's also check the MAC address again. As you can see now, we have the MAC address of the devices of the PCs that are connected to the switch. Now this is where this PC comes into play. So we'll do this. We'll try to put this cable here and try to ping from this device and see what happens. Let's assign IP address to this device. As a matter of fact, let's assign the same IP address to the device and see what happens. And if we try to ping from this device to any other device, as you can see, it went from green to red because we've already told this interface FA0/1 that it should only recognize the MAC address of this PC over here. So if any other PC with a different MAC address tries to access the port of FA0/1, we want that port to go down. Now at the moment, this PC cannot do anything with this port FA0/1 because that port already recognized the MAC address of this PC over here. Now if we also try to do this, we can go to the switch. We can go to the switch and say interface FA0/1 and we say no shot. It's still down because the MAC address, as I said, is different from the one that was stored in the switch. Now let's bring this back to the original device. Let's put this back here, and yes, it's still going to be on the shutdown state because there was an unrecognized device that tried to access the port. However, let's try to say no shutdown again, since it's connected to the actual device, FA0/1. We want to say shutdown and no shut. So by doing that, the interface is back online. I'm sorry I did not do no shutdown earlier, but we can still do that. We can still take this from here and still plug it back here and wait for it to come back on. As you can see, guys, it's back on and it's green. So let's try to ping once again and see what happens. You see, the moment we try to ping, it goes back to red, meaning it's in the shutdown state. Now let's try to do shutdown and no shut. It's back on, right? So now let's try to ping again and see what happens. Let's wait for it to come back to green and we try to ping one more time. As you can see, it's now in the green state, so let's try to ping and see what happens. Once again, it has gone down because the MAC address is not what the switch knows. The switch knows a different MAC address which belongs to this PC, and this one has a different MAC address, so it's not going to work. Now let's bring the cable back to this PC and try to ping from here. We say no shut. Oh, first of all, we say shut down. Then we say no shut. Now it's back. Let's also try to ping when the device goes to green. Let's try to ping a different device on the network, 192.168.1.4. So as you can see, we are able to ping from the original device that the switch knows the MAC address to one of the devices on the local area network. Let's also try with the other devices on the local area network. Let's try the switch knows the MAC address of this PC, so let's give the cable to this guy. And for interface FA0/2, FA0/2, we told for interface FA0/2, the violation is restrict, and what restrict means is it drops the packet and sends a log message. The interface does not change to red like the shutdown states, but any packet that was sent will be dropped, as even ping would not be able to go through. Let's try to ping from is that the device FA0/2. So let's try to ping from this device. It is not going to go through, but it's still going to remain at green, that it's active, but packets will not go through. So that's how restrict and protect work. Port security violation modes and how it works. So the protect mode drops the packets from unknown MAC address, but it does not notify the administrator about what's going on that interface. While the restrict mode drops the packet and sends a log message, and shutdown mode puts the port into an error disable state, meaning the port goes down and it can only come back up when the PC whose MAC address is supposed to match that interface is plugged in. In conclusion to this, port security is a vital network security measure that ensures only trusted devices can access the network. It strengthens network defenses against unauthorized access as it improves monitoring and it also helps to maintain a secure local area network environment. With that being said, I believe this video have helped you to understand how port security works and how to protect the ports on a switch. If this video helps you, it's going to be very helpful if you like and subscribe and share this video, and I hope to see you in the next class.